hope you all are safe at your places. And we were doing lesson number 2, that is your structure of an atom. And topic for today's video is development leading to Bohr's model of an atom. Now, what were the factors, what were the reasons for the discovery of Bohr model of an atom? We'll discuss them all one by one. So we'll start with very first. So it was observed that all the elements give characteristic line spectrum, that is your emission spectrum. Now the question come in your mind is, what is spectrum? So you all have seen prism, and when you pass a white light through prism, so color of a band of 7 colors is formed on screen. The band of 7 color is formed on screen. This band of 7 color on screen is known as what? Spectrum. This is known as spectrum. Clear? The spectrum may be continuous, the spectrum may be discontinuous. I'll take one more example. For example, you are having a tube which is filled with your any gas molecules. For example, if it is filled with your what? Hydrogen atoms, and you'll heat it, it will emit some radiations. And when these radiations are passed through prism, so again on screen we'll get some colored lines. These colored lines may be continuous, this may be non-continuous. For example, here we are having violet, blue and your red. And rest all the colors are what? Absent. And those colors are absent, there dark lines will appear. Clear? So these lines are known as what? These colored lines are known as what? Spectrum. Clear? So these band of colors is known as spectrum. So spectrum may be continuous, it may be discontinuous. That will study in your emission and absorption spectrum. Now we'll move to our topic. So it was observed that all elements give characteristic line spectrum, that is emission spectrum. Now in order to understand line spectrum, it is essential to understand the nature of your light. अगर हम लोगों को आपके पास लाइन स्पेक्ट्रम को समझना है कि ये लाइंस क्यों आ रही हैं, क्यों नहीं आ रही, तो सबसे पहले हमें नेचर ऑफ लाइट को समझना पड़ेगा. तो इसके लिए आपके पास 2 साइंटिस्ट ने 2 अलग अलग थ्योरीज दी. द फर्स्ट attempt was made by in order to understand nature of light, the first attempt was made by your James Clerk Maxwell. In your 1864, he put electromagnetic wave theory, and then after was described by Planck in Planck's quantum theory. Planck in your 1900 in Planck quantum theory. So this is classical theory, this is your what? Quantum theory. So nature of light was discovered by 2 scientists. The first attempt was made by your James Clerk Maxwell in 1864. He explained electromagnetic wave theory, and then after was explained by Planck in 1900 in Planck quantum theory. Clear? Further, when electromagnetic wave theory was put forward, Rutherford model of an atom suffer from serious drawback, which leads to discovery of new model of an atom, which is known as your what? Bohr's model of an atom. And your Bohr model of an atom was very much able to explain main lines of hydrogen spectrum, which was not explained by your Rutherford model of an atom. So in order to understand nature of light, we'll firstly discuss electromagnetic wave theory. So we'll start with electromagnetic wave theory, and we'll discuss the postulates of electromagnetic wave theory. Electromagnetic wave theory, which was given by your James Clerk Maxwell in 1864. So what was his first postulate? His first postulate is that the energy emitted from any source continuously in the form of radiation and is called radiant energy. अगर कोई सोर्स कंटिन्यूसली एनर्जी एमिट कर रहा है, क्लियर, तो वो एनर्जी रेडिएशंस की फॉर्म में निकलेगी और उसे हम रेडिएंट एनर्जी कहेंगे. फॉर एग्जाम्पल, इफ यू आर हैविंग अ सन एंड इफ सन इज कंटिन्यूसली giving what energy, if sun is continuously emitting energy, so this energy must be in the form of what, radiation energy. This energy is must be in the form of what, radiations, और इसे हम लोग क्या कहते हैं, radiant energy. Radiant energy. Another example, if we heat your iron ball, clear, it will heat what, iron ball at your 500 degrees Celsius, and if you stand near this iron ball, what you'll feel, you'll feel hotness. Why? Because this iron ball is continuously emitting energy in the form of what, radiations, and that is known as what, radiant energy. So this was his first postulate, and his first postulate is the energy emitted from any source continuously, like your sun, your hot iron ball, your rod, continuously in the form of radiations, and it is called radiant energy. So I'm writing here first postulate, the energy emitted from any source continuously, these energy emitting sources may be your sun, your bulb filament, your hot iron ball, and your what, rod, any ignition rod. Clear? So the energy emitted from any source continuously is in the form of what? Is in the form of radiations, and is called radiant energy. Clear? So if any source is emitting energy, if any source is emitting energy continuously, so it will emit energy in the form of what, radiation, and it is known as what, radiant energy. Clear? And this energy of any electromagnetic radiation is directly proportional to intensity and independent of frequency. So the energy of any electromagnetic radiation is, write down, note here, and we'll discuss this point later. Note, the energy emitted, clear? So the energy emitted by any of electromagnetic radiation is directly proportional, समझाते हैं अभी क्या है, proportional to intensity and independent of frequency and wavelength. So your first postulate is, if the energy emitted from any source continuously, if the energy is emitted from any source is continuously, it will be in the form of what, radiations, and this is known as what, radiant energy. Now this energy emitted by any of an electromagnetic radiation is directly proportional to intensity. For example, अगर हम बात करते हैं, intensity means what, brightness, mainly intensity deals with brightness, कि अगर आप लोगों ने एक हीटर लगाया हुआ है और उसकी आपने फर्स्ट, उसमें 3 पॉइंट्स होते हैं, फर्स्ट, सेकंड, थर्ड, क्लियर, और उसमें एक रॉड है. अगर आपने फर्स्ट रॉड जलाई तो उसमें आपके पास, जब हम उसको हीट आप हीट कर रहे हैं, आप उसका वोल्टेज बढ़ा रहे हैं, तो आपके पास क्या कर रही है, वो थोड़ी सी उसकी इंटेंसिटी या ब्राइटनेस बढ़ रही है। आपने सेकेंड मोड ऑन किया तो उसकी ब्राइटनेस और बढ़ेगी, थर्ड मोड ऑन किया तो उसकी ब्राइटनेस और बढ़ेगी। तो जैसे जैसे आप एनर्जी बढ़ाते जाते हैं उसकी ब्राइटनेस क्या करती जाती है, बढ़ती जाती है, मतलब इंटेंसिटी बढ़ती जाती है। तो इलेक्ट्रोमैग्नेटिक वेव थ्योरी बोलती है कि जैसे जैसे आप एनर्जी को, किसी भी सोर्स की एनर्जी को बढ़ाएंगे तो उसकी इंटेंसिटी बढ़ेगी, ना कि उसकी फ्रीक्वेंसी और वेवलेंथ। क्लियर? सो if we are increasing energy of any source, so it will lead to increase in what, intensity, and it is independent of frequency and wavelength। कि हम किसी भी चीज को अगर हीट करेंगे तो उसकी ब्राइटनेस बढ़ेगी, ना कि उसकी फ्रीक्वेंसी या वेवलेंथ, उसके कलर में कोई चेंज नहीं आएगा। क्लियर? सो दिस, जैसे आप लोगों ने बल्ब लगाया होता है, वोल्टेज कम होता है, वोल्टेज ज्यादा होता है, तो वोल्टेज कम हो तो वो डिम हो जाता है, वोल्टेज ज्यादा हो तो वो क्या हो जाता है, ब्राइट हो जाता है ना। सो यही बोला है आपके पास किसने, योर इलेक्ट्रोमैग्नेटिक वेव थ्योरी ने। सो एनर्जी ऑफ एनी इलेक्ट्रोमैग्नेटिक रेडिएशन, एनर्जी ऑफ एनी electromagnetic radiation is directly proportional to intensity. Clear? So if we are increasing energy of any electromagnetic radiation, उन्होंने बोला कि अगर हम एनर्जी को जितना मर्जी इंक्रीज कर लें, सिर्फ ब्राइटनेस बढ़ेगी और उसकी फ्रीक्वेंसी या वेवलेंथ, मतलब कलर में कोई चेंज नहीं आएगा। ये बोला था इलेक्ट्रोमैग्नेटिक वेव थ्योरी ने, दैट योर एनर्जी ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशन इज डायरेक्टली प्रोपोर्शनल टू व्हाट, इंटेंसिटी, एंड इट इज इंडिपेंडेंट ऑफ व्हाट, योर फ्रीक्वेंसी एंड wavelength. This is very very important point, and remember this, that energy of electromagnetic radiation is directly proportional to energy. So energy emitted by any of your electromagnetic radiation is directly proportional to intensity. Clear? और energy of EMR भी बोल सकते हो आप लोग। Clear? So this is first postulate. Second postulate, your second postulate states that the radiations we are talking about what, radiations, कि अगर आपके पास कोई भी सोर्स एनर्जी एमिट करता है तो एमिट करता है इन द फॉर्म ऑफ व्हाट, रेडिएशंस। नाउ सेकंड पोस्टुलेट इज दीज रेडिएशंस कंसिस्ट ऑफ इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड। कि अगर हम बात करें इन रेडिएशंस की तो इसके पास इलेक्ट्रिक फील्ड भी है और आपके पास क्या है, मैग्नेटिक फील्ड भी है। दैट्स व्हाई दे आर नोन एज व्हाट, इलेक्ट्रोमैग्नेटिक waves. Clear? So these radiations consist of electric field component, is having electric field component, and this one is what, magnetic field. So which one is with blue shade is known as electric field component, and which one is with what, blue shade colorless is your what, magnetic field component. So this second point states that your radiations radiation consists of electric field as well as magnetic field. Clear? So radiation consists of electric field as well as what, magnetic field. Clear? And they both are perpendicular to each other, and they both are oscillating perpendicular to each other and to the direction of propagation. What this point states कि आपके पास जो रेडिएशन है उनके पास इलेक्ट्रिक फील्ड भी है और मैग्नेटिक फील्ड भी है, इलेक्ट्रिक फील्ड भी है और मैग्नेटिक फील्ड भी है, और ये दोनों एक दूसरे के परपेंडिकुलर का मतलब कि अगर एक रेडिएशन इस तरह से ऑसिलेट कर रही है तो दूसरी इसके परपेंडिकुलर इस तरह से ट्रेवल करेगी। क्लियर? अगर आपके पास एक वेव इस तरह से ट्रेवल कर रही है, क्लियर, ऊपर और नीचे ट्रेवल कर रही है इस तरह से, तो दूसरी वेव कैसे ट्रेवल करेगी, इस तरह से। सो दे बोथ आर परपेंडिकुलर टू ईच अदर. क्लियर. सो एक वेव अगर ऐसे ट्रेवल कर रही है तो दूसरी वेव कैसे ट्रेवल करेगी, इस तरह से. सो इलेक्ट्रिक फील्ड कंपोनेंट एंड मैग्नेटिक फील्ड कंपोनेंट, दे बोथ आर परपेंडिकुलर टू, दे आर ऑसिलेटिंग परपेंडिकुलर टू ईच अदर एंड टू द डायरेक्शन ऑफ प्रोपोगेशन. दिस डायरेक्शन में वो चल रहे हैं. क्लियर. सो सेकेंड कंपोनेंट इज, सो योर radiation consists of electric field as well as magnetic field and they both are oscillating perpendicular to each other. एक दूसरे के तो perpendicular हैं ही, साथ में जिस direction में चल रही हैं उसके भी क्या है, perpendicular. जिस direction में propagate कर रहे हैं उसके के भी क्या है, perpendicular है. Clear? I hope this point is clear to you. Still you are having any doubt, you may ask. Clear? Now third one, the radiation possess what, wave character. We are saying what, electromagnetic wave. Now why electromagnetic? Because they are having electric character as well as it is having electric component as well as magnetic field component. Now why wave? Because these radiations contain what, wave character. So third postulate is, these radiations possess wave character and, very important, they travel with velocity of light. Now tell me, what is velocity of light? Think of light before I'll write velocity of light. That is 3 into 10 raised to the power 8 meter per second. So these radiation possess what, wave character. ये किसकी तरह चलती हैं, wave की तरह चलती हैं, और इनकी जो velocity है that is same to that of what, velocity of light, that is 3 into 10 raised to the power 8 meter per second. So this is third postulate of your what, electromagnetic wave theory. I hope this is clear to you. Now fourth, as I'm talking about sun, I'm again and again giving example of sun, कि आपके पास sun, आप यहाँ पे खड़े हैं, अर्थ में खड़े हैं, और आपके पास क्या है, आपके पास सन की रेडिएशंस आ रही हैं. तो सन की रेडिएशंस क्यों आ पा रही हैं, क्योंकि दे डू नॉट रिक्वायर एनी मीडियम फॉर प्रोपोगेशन. क्लियर. सो radiation, these waves do not require, these radiations do not require any medium for propagations. That means your electromagnetic waves do not require, क्योंकि बीच में वैक्यूम भी है, तो अगर मीडियम चाहिए होता तो सन की रेज तो हमारे तक कभी नहीं पहुंचती. क्लियर. सो योर फोर्थ पॉइंट इज, electromagnetic waves do not require any medium for propagation, just like sun rays, just like sun rays. Clear. So electromagnetic waves do not require any medium for propagation. This one is fourth postulate. Fifth postulate, they never, as they are having what, electric field component and magnetic field component, so they never deviate in electric and magnetic field, but they generate what, electric and magnetic field during propagation. So this point is very important, although this is not written in your book. So they never deviate in electric field and magnetic field, but they generate electric field and magnetic field on propagation. So these were the postulates of your electromagnetic wave theory. So what was the first postulate? First postulate was the energy emitted from any source continuously is in the form of radiations, and it is known as what? It is called radiant energy. Clear? Second point is, these radiations possess your electric as well as what? Magnetic character. Clear? So these radiation consist of electric field as well as magnetic field, and they both oscillate in what? They both oscillate perpendicular to each other and perpendicular to the direction of motion. Clear? Third point is these radiations possess wave character and they travel with a velocity of light, approximately with the velocity of light. Fourth property, electromagnetic wave do not require any medium for propagation. And last one, they never deviate in electric field and magnetic field, but they generate electric and magnetic field on propagation. I hope these points are clear to you. Now we'll start with characteristics of wave. How we can define wave. So very first characteristic of wave is your wavelength. Wavelength. Clear? So what is wavelength? So this is your what? Wave. If we'll consider this, so this one is your what? Wave. Clear? And this one is known as what? Crest. And the lines which are below this, the wave, the part which is below this is known as your what? Trough. Clear? So this is known as crest. And this is known as what? Trough. Clear? So what is wavelength? So wavelength is defined as the distance between two consecutive मतलब साथ वाले. Clear? So distance between two consecutive crest or two consecutive trough is known as your what? Wavelength. Clear? So and this is represented by what? Lambda. So what is wavelength? So wavelength is distance between two consecutive crest or two consecutive trough is known as wavelength. Clear? So wavelength is the distance between two consecutive crest or two consecutive trough is known as wavelength. Wavelength. Now how your wavelength can be represented? So wavelength is what? Length. Clear? Distance, length. So this can be represented in what? Angstrom. So 1 angstrom is equals to 10 raised to the power minus 8 centimeter, which is equals to 10 raised to the power minus 10 meter. So this can be represented in angstrom, centimeter, meter, nanometer. 1 nanometer is equals to 10 raised to the power minus 9 meter. And if we'll talk about picometer, so 1 picometer is equals to 10 raised to the power minus 12 meter. So your wavelength can be represented in angstrom, nanometer, picometer. Clear? So this is about wavelength. So distance between two consecutive crest और टू कॉन्जिक्यूटिव साथ वाले इज नोन एज व्हाट? ट्रफ. अगर हम यहाँ से लेके यहाँ तक चलें तो दिस इज व्हाट? योर वन वेव. अगर यहाँ से लेके यहाँ तक चलें तो दिस इज योर व्हाट? वन वेव्स. एंड दिस इज नोन एज व्हाट? वेवलेंथ. एक वेव की लेंथ इज नोन एज व्हाट? वेवलेंथ. देखिए यहाँ से स्टार्ट किया, ये यहाँ पे खत्म हो गया. दिस इज व्हाट? वन वेव. क्लियर? एंड लेंथ ऑफ वन वेव इज नोन एज व्हाट? वेवलेंथ. नाउ सेकेंड वन इज योर फ्रीक्वेंसी. फ्रीक्वेंसी. Clear? Frequency, which is represented by what? Nu. Clear? Nu. Done? So what is your frequency? So number of waves travel in 1 second. 1 second में आपने कितना काम किया? That is what? Frequency. So number of waves travel in 1 second is known as frequency. Clear? So number of waves travel in 1 second is known as frequency. So what will be unit? So it is what? Number of cycles or waves divided by what? Per second. Clear? So this can be 1 divided by what? Number. This is number. So number is having no unit. So 1 divided by second. This is what? Second inverse, which is known as what? Hertz. Clear? Hertz. So frequency is having SI unit, that is what? Hertz or second inverse. Clear? And always remember 1 megahertz is equals to 10 raised to the power 6. Mega means, clear, 10 megahertz. 1 kilohertz, kilo means 10 raised to the power 3 hertz. Clear? 1 microhertz, so this will be 10 raised to the power minus 3 hertz. So this is all about frequency. So what is frequency? So number of waves travel in 1 second. 1 सेकेंड में कितने वेव्स ट्रेवल कर रहे हैं उसे हम क्या बोलते हैं? फ्रीक्वेंसी. 1 सेकेंड में कितने वेव्स ट्रेवल कर रहे हैं उसे हम क्या बोलते हैं? फ्रीक्वेंसी. क्लियर? अगर बच्चे हम बात करें फ्रीक्वेंसी की तो कितने ज़्यादा वेव्स ट्रेवल करेंगे 1 सेकेंड में उसे हम क्या बोलते हैं? फ्रीक्वेंसी. 1 सेकेंड में कितने ज़्यादा वेव्स ट्रेवल कर रहे हैं. क्लियर? Now we'll move to next one, and that is known as velocity. Velocity of a wave. Velocity of wave. Before velocity we'll do amplitude. We'll do amplitude first, then after we'll talk about your velocity. Amplitude. Clear? So what is amplitude? Amplitude is a height of crust or depth of trough. Clear? Simply, amplitude of a wave is nothing but a height of crest or depth of trough. So amplitude of a wave represents height of crest or depth of trough. Clear? For example, here we are having wave. So we are having 2 waves. For example, we are having here 2 waves. So one is having amplitude this and another is having amplitude this. Clear? So amplitude is what? Amplitude represent height, and this we'll represent with A. Clear? So symbol for representing amplitude is A. So amplitude represents what? Height. Height of crust. Height of what? Height of your what? Crust or depth of trough. Clear? And your amplitude is directly proportional to the square root of intensity. उसको हम बाद में करेंगे. जितना बच्चे हमेशा याद रखना, जितना ज़्यादा amplitude होगा उतनी ज़्यादा क्या होगी? Brightness. Higher the amplitude, more will be the brightness. अगर यहाँ पे हम बात करें amplitude की, तो amplitude, and this relationship you'll study in your 12th class, amplitude is directly proportional to the square of intensity. So more will be the amplitude, more will be the height, more will be the brightness. और competitive में question आता है कि इन दोनों में से किसकी brightness ज़्यादा होगी? तो जिसका amplitude ज़्यादा होगा that will be more brighter. So this is having what? Higher amplitude. Therefore more will be what? Brightness. Clear? More will be brightness. Done? So what is amplitude? Amplitude represents height of crust or depth of trough. Again, what will be the unit? So this is what? Height. That is what? Distance basically. Clear? And your distance is expressed in what? Meters, centimeter. Clear? So units will be what? Your meters, centimeters. The centimeter, this will be your what? Angstrom. This will be your unit for representing amplitude. Clear? Then after will be your what? Wave number. Wave number. Wave number. Clear? So wave number is represented by mu bar. Wave number is represented by mu bar. So what is wave number? Wave number is defined as number of waves present in 1 centimeter. 1 centimeter में कितनी waves present है, that is known as what? Wave number. So wave number represents number of waves travel in 1, or number of waves present in 1 centimeter. Therefore your wave number is reciprocal of what? Your wave length. So this is a relationship between what? Wave number and wavelength. They both are what? Inversely proportional to each other. Clear? And last one is your velocity of wave. So what is velocity of wave? Distance traveled by a wave in 1 second. Distance traveled by, frequency और आपके पास velocity में यही difference है. frequency क्या है? कितनी waves travel की 1 second में. Clear? और आपके पास velocity क्या है? कितना distance travel किया 1 second में. That is your what? Velocity. In frequency we use what? Number of waves, and in velocity we use what? Distance. Clear? So in velocity we talk about distance traveled by a wave in 1 second is known as velocity of wave, and represented by, this is represented by c. Clear? This is represented by c. So distance traveled by a wave in 1 second is known as what? Your velocity of a wave. Clear? As we know, we measure distance in what? We measure distance in your meter, centimeter, है ना? So the units will be meter divided by what? Second. So we may write like this: meter 1 upon second. Clear? Units will be what? Meter per second. But see what we are trying to drive. Meter is the unit of what? Wavelength. 1 upon second is a unit of what? Frequency. So your velocity is equals to wavelength into what? Frequency. So this is a relationship between velocity, wavelength and frequency. Clear? So relationship between frequency, velocity and your wavelength is c is equals to lambda into nu. Clear? C is equals to nu lambda, or lambda is equals to, or nu is equals to c upon lambda. That means your frequency and wavelength are inversely proportional to each other. कि अगर आपकी frequency बढ़ेगी तो wavelength कम होगी, और अगर wavelength बढ़ेगी तो frequency कम होगी. They both are inversely proportional to each other. That's why I have written velocity at last. So what is velocity? Distance traveled by a wave in 1 second is known as your velocity. और हमने यहीं से unit निकाली है. Velocity के units क्या होते हैं बच्चे? Distance is measured in meter, traveled in 1 second, so second will be in at last. So meter is the unit of your what? Wavelength. 1 upon second is the unit of your what? Frequency. So c is equals to lambda into nu, and from here we have calculated the relationship between your lambda and frequency. And in next video we'll find out, we'll talk about electromagnetic spectrum and how your electromagnetic radiations are arranged. All these things we'll do in your next topic along with numericals. Thank you.